I'm Dr. Vikas Singh from ABES Engineering College. Today I am going to discuss about the Compton effect. Outline is introduction and derivation of the Compton effect. In 1921, H. Compton, while studying monochromatic X-ray scattered by carbon atoms, found that when a monochromatic beam of a high energy photon is scattered by a target rich in electrons, the scattered beam contain photon not only the same wavelength as that of incident photon but also the photon of longer wavelength or shorter frequency. Here this is the diagram. Suppose say this is our carbon rich sample and this is the photon. So before collision it's having energy photon is E is equal to h nu and momentum is P is equal to h nu by c, and at that time that electron have the energy E is equal to m naught c square and momentum of that electron is 0. This is the condition before collision. After collision, the photon is going in this direction and having angle theta. Electron is going in this direction, suppose, and having angle phi, and this is the direction of incidence. Okay, so here the energy, or we can say its kinetic energy of the electron is mc square by m naught c square. So the Compton-Driven expression for the change in wavelength of scattered photon, considering the elastic collision between the and the electron of scattered material by applying the law of conservation of energy and momentum. Let's say photon of energy h nu and momentum h nu by c collides with the free electron at rest and give it a fraction of its energy, or we can say transfer to its energy to the electron. Let's scattered photon is emitted in the direction of theta and energy is h nu prime and momentum is h nu by c, and the electron requires at an angle theta phi and momentum is mv. So now according to the principle of conservation of energy, now according to the principle of to the principle of now applying principle of conservation of energy before collision is equal to किसकी होगी, and that energy after collision. That means h nu plus m naught c square, the energy of electron, this is the energy of photon, is equal to energy of photon h nu prime and mc square. Applying principle of conservation of momentum, then there is also momentum before collision. Momentum before collision is equal to momentum after collision. Now here, the momentum h nu by c and the momentum of electron is 0. Momentum is a vector quantity. So here we are resolving the component in horizontal and vertical component. Then h nu by c cos theta plus mb cos phi. And vertical for vertical component, 0 plus 0 is equal to h nu by c sin theta minus mb sin phi, or we can write it as, if we can rearrange, then we can write it at h nu prime by c sin theta, h nu prime by c sin theta is equal to mb cos sin phi. Rearranging equation, this is the equation 1, this is equation 2 and equation 3. Now we rearrange the equation 2 and 3 and we get h by c h by c nu cos theta from this equation. Here we are taking this term in left side is equal to mb sin phi. Now adding and squaring both above this equation number 4 and 5, these equations, then we get squaring and adding the above equation, then we get m square v square is equal to h square by c square nu prime square cos square theta minus 2 nu prime cos theta plus h square c square nu prime square sin square theta. So m square v square c square is equal to h square nu prime square minus 2 nu prime cos theta. Or we can p is equal to, we know p is equal to mb and p square is equal to m square b square. So we can write it as p square c square is equal to h square nu square plus nu prime square minus 2 nu prime cos theta. We know E is equal to mc square from relativistic relation is equal to p square c square plus m naught square c raised to the power 4. Here we can write it as h nu plus m naught c square is equal to h nu plus under root p square c square plus m naught square c to the power 4. This value we are putting in the equation 1 and squaring Here we can write it as h nu minus h nu prime plus m naught c square is equal to p square c square plus m naught square c raised to the power 4. Squaring above equations, then we get h nu minus h nu prime का prime plus m naught c square whole square is equal to p square c square plus m naught square c raised to the power 4. For solving this, we have h nu minus h nu prime square plus m naught square c raised to the power 4 plus 2 h nu prime m naught c square is equal to p square c square plus m naught square c raised to the power 4. These terms are cancelled. Now we get h square nu square plus h square nu prime square 2 h square nu prime plus 2h nu prime m naught c square is equal to p square c square. This equation, suppose say equation B, and this is equation A. From equation A and B, we have h square nu square nu prime square minus 2 h square nu prime square plus 2h 2h nu h square plus nu square plus 2h nu minus nu prime m naught square is equal to c is equal to h square nu plus h square nu prime square minus 2h square nu cos theta. Now these two terms are cancelled out. So this we can write it as minus 2h square nu prime square cos theta is equal to 2h 1 minus cos theta, sorry, 1 minus cos theta 2h nu prime m naught square c. Here h square, this h is cancelled, nu prime is equal to h nu prime 1 minus cos theta divided by m naught c square. Or we can write it as 2h nu prime m naught c square is equal to 2h square nu prime 1 minus cos theta. So here we get this 2. Here we get 1 upon nu prime minus nu is equal to h upon m naught c square 1 minus cos theta. If we can write it as in terms of wavelength, so this can be written as delta lambda is equal to h upon m naught c 1 minus cos theta. This is the expression for the Compton shift. And here we can see that as the value of m naught and c square are positive, the maximum value of cos theta is 1 in this case. And nu is always greater than nu prime. That is, the frequency is incident photon is always greater than the frequency of scattered electron. In delta lambda terms, we can also say expression for the Compton shift, and delta lambda depend upon the angle of scattering is independent of wavelength of incident photon. So this is the expression for the Compton shift. Now these are the references